Hey yo, TTTJ, and welcome back to my channel. Today I'm gonna bring you another Mastercam tip video. The topic is how we can do the chamfering toolpath on a steep surface. And this is not the first time I make a video about this. If you follow my channel, about 3 years ago I made another video on the same topic. And this is that's how we can chamfer the whole on edges on steep surface. So in this video, the way I use is using a flow light toolpath. We need to modify the part, and then we use a flow light toolpath to make the chamfer. But today in this video I'm gonna show you I think a better way to do that. We can use a chamfer tool instead of a ball mill, and we can use more simple toolpath. Okay, and here we go. You can see on the screen I have the part just for demonstration. This is the part, and on the part I have some slot that we need to do the chamfering. Okay, and the key thing is you can see I have two surfaces. The first one on the left and the second on the right. You can see this is the angle. This is the angle of the surface. For the left hand, the angle is 15, and on the right I have a 30-degree angle surface. So we can consider this one. This one on the left is a shallow surface, and the other one is a steep surface. Okay. So this one on the right side is a steep surface, and you know, if you ever try to do a chamfer on a steep surface, you can see the problem. Okay, I'm gonna show you. I just want to show you again. Wait a minute. Okay, so I just define the stock. And this is the chamfer toolpath on the shallow area or shallow surface. Let's see how it looks. And this one is on the steep. Yeah, you can see the problem. On the shallow area, we have it look quite constant for the chamfer Y. The Y of the chamfer is quite constant. It's just a little different between here at the bottom and here on the top, but not so much different, so it can be acceptable. But when you come to here on a steep surface, you can see the chamfer Y is smaller than in the bottom than the top. You can see this is on the top of the slot because of the contacting error. We got a very big chamfer here, and sometimes it cannot acceptable. It look very bad. Yeah, it depends on you. Sometimes you want something look like this, but sometimes it cannot acceptable because the difference is too much. So this why I make this video. I'm gonna show you how we can make a constant chamfer white on a steep surface like this. I'm gonna show you. Okay, I'm gonna show you. Okay, I will verify two toolpaths so you can see the difference, and you will understand what I mean if my English is not so good. All right. Okay, the first toolpath is the 3D chamfer. Yeah, this is 3D chamfer toolpath in Mastercam. And the second, this is the secret toolpath with some trick. Go with it. I'm gonna show you later. Okay. Let's see how it's work. Really? You're kidding me? See that? Did you see the difference, right? Okay, so you can see the difference. On the left side, this one and this one, I use traditional Mastercam 3D chamfer toolpath, and this is the result. And the second thing, my secret toolpath with some trick behind that, and you got this result. So it depends on you. Maybe you may like this one, but in this case I like this one because the chamfer, the Y of the chamfer is constant. Yeah, and this look cool to me, not this one. See that? Okay, so I'm gonna show you the trick. We back to our park. Okay, and see it again. You can see the first one, the first toolpath, I use a 3D chamfer. So I select this chain and this chain, and in the parameter here, cut parameter, I select 3D chamfer. I input the chamfer white and the bottom offset. But the best thing is, for this toolpath, Mastercam doesn't know what is the part, so it don't care how much material it will take. It just follow the curve, something like this. So we got a bad result here in this area. You can see we have a very large contact error, so that's why we have a very big chamfer. That's sometimes it's very bad, so I don't want to do that. You can see we got a big chamfer here, and when the tool move to the bottom here, we got a much smaller chamfer, so it's very difficult to control the toolpath, especially on the steep surface. So I only use a 3D chamfer for shallow surfaces like this surface. I can use 3D chamfer. A little different is not so important, but for the steep surface, it's not my choice. Okay, you can see I have another toolpath that's called surface high speed project. Yeah, this is the project toolpath. You can also have you can find another traditional project toolpath. It's just a new one, so it's called surface high speed, and this is how it's go. You can see that with this project toolpath. Let's see what result we got. Oh, I will be back, and I will verify the first chamfer and the surface high speed project, but I want to show you how I go with this. Yeah, with this project toolpath, I make a original toolpath for projection. Like you can see here, I have a 3D chamfer, and I have some curve here already created. The first step, I select the 3D chain here. You can see when we will look to the top, is the 2D chain of the slot edge here. So I make a 2D chamfer. You can see this is the original chamfer toolpath based on this 2D curve with the 0.5 chamfer Y and 0.5 bottom offset. And then what I did is I gonna project this chamfer toolpath on this surface, on the part. I'm gonna show you. We're gonna open the project toolpath, and you can see the green surface I selected, and the wall stock and the floor stock I input minus 0.3 so it can cut into the surface. Alright, and for the cut parameter, in the projection type I select NCI, so the NCI data will be converted from the 2D chamfer to this project toolpath. Okay, and let's see how it works. Just do a test with this toolpath. You can see this is how it works, and we go back to see the result. You can ghost this toolpath, so make sure it's gonna be positive. Okay, so I just verify these toolpath, the 3D chamfer and the project toolpath. So this is the 3D chamfer. Yeah. And this is the project toolpath. And this toolpath is projected from a 2D chamfer. Let's see if we have any different. You can see that we don't have so many different. Let's see. When I look from the top, yeah, just a little different. You can see here in this area we have a transition for the 3D chamfer. We have something like a golfing, but we have a smooth transition here for the project toolpath. You can see this is smooth, and you can see we have a small golfing. Yeah, it's not so good. But if we talk about the chamfer, the Y of the chamfer is the same when we compare to toolpath. The chamfer and the 3D chamfer and the project, they are the same results. We still have a big chamfer here and a small chamfer here. So that's what we don't like. Okay, what we don't want. So what is the secret here to make a constant chamfer? Okay. Now you can see my secret toolpath. That is the project. This is my secret toolpath. But how we can make the chamfer constant? You can see we have a very small chamfer here, and it's still small here. Yeah, you can see. So how did I do that? Okay, I'm gonna show you right now. I don't want to make you waiting. Okay. So this is the secret toolpath I told you, the project toolpath. But we need some trick to make it work, because you know, for this toolpath, this is also a project, but the chamfer is very big. See that? You can see here. Oh, sorry. The chamfer is still big, and this is the trick I'm gonna show you. Let me turn on some level. Okay, so here this is the trick. This is the secret. Let's see that. I'm gonna backplot the toolpath so you can see. You can see this surface, this surrounding surface. Yeah, that's the key. I use that surface for controlling the Y of the chamfer, and I'm gonna show you how to make this surface very easy. And you see when the tool come here, the tool is retract, it go up, and it keep contacting with this surface. And that's how we keep the Y of the chamfer constant. Yeah, this is the trick. You can see that. So there's no way the tool can cut more into the material. For this project toolpath, we don't have the sorry. Oh, maybe I move it up. Sorry, I will bring it back. Okay. This is the second toolpath, second project toolpath. You can see I don't have the control surface here, so the tool cut into the material much and get a lot of material, and we have nothing to control that. But for this one, I'm gonna turn off the curve so you can see it clearly. You can see I use this surface, this orange surface, to control the contact point, control the contact area. So that's how we make a constant chamfer. You can see the distance between this edge to the surface is constant. I make it 0.5. Okay, that's how I can control the toolpath. Very easy, right? So how I did it. Let me show you. So this project toolpath is also use the data, the NCI data from 2D toolpath, 2D chamfer. This is the number 4 here. You can see I use a 3D contour, 3D chamfer for making the toolpath, making the NCI. So, and the next toolpath, the project, it will use the NCI data from this toolpath and project it to the surface we selected. Okay. I'm gonna open the project toolpath so you can see the surface I selected. Level. Instead of select the solid surface, I don't select it. I don't select them. You can see this is the surface I selected. Surfaces, 4 surfaces, and later I'm gonna show you how I have this flat surface here. Okay. So you can see for the cut parameter, I select the NCI for projection type. So I got the data from the toolpath, number 4 toolpath, and I project the toolpath to these 4 surfaces. Okay. So what happened if I don't select the 2 surfaces? I just select this one and this one. I'm gonna show you what happened. Now we only select 2 surfaces, the small one here and the small one here, and we generate the toolpath again. You see that? We don't have a complete toolpath. I really don't know why it's be like this. On this side we have a complete toolpath, but on this side we miss this edge. You can see for the left side it's okay, but for the right side I don't know what happened with the projection. If we only select this one and this one, I think it's like something the Mastercam is unable to find the surface to do the projection. So that's why it skip this error, and it start from here, not from here. But the best thing is it happened to the right pocket, but it doesn't happen to the left pocket. Yeah, maybe because of the angle of the surface or something. But to solve this problem, I create this surface and this surface. Yeah, just make I call it the surface for projection. You can see when I select them, this one and this one, we have a full projection, and the toolpath is continuous. It's not interruption. It's not interrupted. Yeah, you can see now. Let's go. So we got a full toolpath. If we select this and this, you can see during the you can see this toolpath. The tip is can find somewhere to do the projection. Yeah, you can see before it hit the chamfer, it hit the edge of the chamfer. It follow this surface. So that's why I create this surface and this surface, just for a complete toolpath, not interruption, right? Okay, I hope this makes sense, right? And so that's the trick. You just select a project toolpath with the same tool with this toolpath. I call this the original toolpath. Normally I will ghost it, so we are not going to pause it when we run the program. We just run this one, and you can see it's use the same tool, 6mm chamfer, and this is a project toolpath. I'm gonna show you again the surface I selected. This is the control surface I use. I call it the control surface. You can see the distance from the edge to the surface is constant. That's how we keep the chamfer white constant. Sorry if I talk too much. Okay. And I also need the two surfaces at the bottom for projection, for continuous projection. That's what I call. Okay. It's very simple, right? And now I'm gonna show you how I create these control surface. If you don't know, I think it's very simple, but if you don't know how to create them, I'm gonna show you. Okay, now I will delete them, and I make them again. I create them again. Okay, now I lost the surface. So to make the control surface, you can do like this. You can see we have two angle surface here. The first thing you need to do is make the plane on these surfaces for creating the curve or something. So you can make the plane. I will remove them and I create them again so you can see. Okay, now I remove the plane I created. I make it. Now we have this one and this one, so I need to make two plane on these surface. I'm gonna make plane from solid face and I pick this steep angle. You can see the Z direction go outside. Okay, and I make another one for, I called it 30 degree. Okay, and I do the same for the for the shallow surface. Solid, pick this. Okay, we just care about the Z direction, and I call it 15 degree. Okay, we're gonna work with the 30 degree first. Okay, I will move the construction plane to this so we can do with curve. Sorry. Okay, now we need to make the curve from the edge. I got here. Curve on one edge. I want to make curve on these edges. This one, this one, this one, this one, this, ding, ding, ding. Okay. And now I got the curve surrounding this edge. The next thing I have to do is doing an offset. Depend on the width of the chamfer you want. For example, you want a 0.5 millimeter chamfer width. Yeah, 0.5. So you're gonna make a 0.5 offset. We go to offset here and chain, and we can select this chain. Okay, and we select the offset direction. I can offset to the outside. Yes, okay. Pick a point on the outside. You can see we have an offset curve, but it's not so smooth because this is a spline, and when the Mastercam do the offset, this will become polyline. So the next thing you need to consider is the tolerance of the offset. If you want a smooth chamfer toolpath, you need to make a smooth surface. So that's why I normally make this 1000 for the tolerance. So you can see you have a smooth curve here. That's the key thing we make. We can make a smooth surface. All right. We have one curve here, and I can make another one here. Yeah, two curves. So we can make a flat surface between this curve and this curve. Yeah, very nice. Okay, very simple. And the next thing, we make a flat surface by using the flat boundary function here. I select this curve and this one. Okay, So very easy, very simple. That's how I create a control surface. You can see the distance from here to here, here, we have a constant distance 0.5. Very simple. Yeah, I just need a small surface for controlling the tool. No need to make a big surface. Alright, and I can make another flat boundary here. Okay, this is the surface I use for the projection. I will move it down later. Okay, now we are finished with this side. We go to the other side. I go to plane. I select the 15 degree. Okay, and now we do with this side. We do the same step. We repeat the step, making the curve on the edges. Okay, and after that we do the offset, and we use the same value for the offset. Okay, if you want to make a 0.5 chamfer, just input 0.5 here. Yeah, take into account to the tolerance, so we have a smooth here. Okay, I want to make it smooth, and another curve. Then we can make a flat boundary surface. Oh, sorry, this one and this one. Okay, and we make another one here for controlling. Yeah, now we back to the top plane. Okay, and then you can move it down because you don't want to lift this surface here, because if you lift surface here, the tool tip cannot go down. Okay, for example, I select this one and this one, this one and this one. Let's see how the tool going. I generate the tool path again. So you can see if we leave this big surface here, the tool tip will follow this surface and it cannot cut into the material. Yeah, that's why we need to move it down. So we need to move it down enough so the tool can contact to this surface. I try to move it down 5 millimeters. So, alright. Now you can see when we move the surface down, we can see the tool the tool can touch this surface. You don't want to move it too deep because the tool will move so deep before it go up here. So just move the enough value. You don't want it to move the surface too deep. Okay, so this is our chamfer tool path with the lead in and lead out. So very nice, right? Very nice and very simple. This is the secret for today. Okay, you can go to the linking and you can change the lead in and lead out curve. Okay, check it again. Yeah, we have a small lead in and lead out. You can move the surface up. But you just need enough value, not too much, not too little, so the tool can touch this surface without any problem. Yeah, that's how it goes. Yeah, this is cool, right? I hope you like it, and I think it can be useful. And there's one thing to remember: if you want to get a smooth surface, because this is a 3D tool path, so you want to set this cut tolerance. The tolerance is as low as possible. So we got a smooth tool path, and then there we got a smooth surface. Okay, very simple, right? we have two chamfer, 2D chamfer here. Oh, I need to unghost it, and we use these two chamfer for this projection toolpath like this. Very simple. Very smooth, right? You can see when the tool go here, it automatically go up to follow this control surface. That's the key how we control the wire of the chamfer. Very easy, and that makes sense, right? Okay. And that's another thing. My opinion, I always try to keep this value in the original toolpath, or original chamfer toolpath. I also I always try to keep the bottom offset at as low as possible. For example, here you can see I have a 0.5 and 0.5 for bottom offset. If I gonna use 1 for chamfer, for bottom offset value, you may have a problem, because when you go you make the tool go too deep, it will be difficult to follow at the corner, to follow the edge at the corner, and you may have some interruption on the surface. So that's, let me show you first. All right. Okay. You can see here, when I use a big value for bottom offset, you may encounter some problem like this. You can see. And when I change this to 0.5, and we generate this toolpath again, yeah, the problem can be solved. So it's just appearance. My opinion, I try to keep I try to keep this value as low as possible. I don't want to move the tool. I don't want to shift the tool too much. I just want to keep it as a enough value, not so deep. In this case, 0.5 for chamfer white and 0.5 for bottom offset. Okay, and I got a good result for the chamfer. So it just works for this case. Maybe you meet other case more difficult, so you need some adjustment and you need some try with this value. Okay, but in my part, this is it seems to be the great value. Okay, so that's the tip for today. It's a secret, right? I hope this will be useful and we can take a look on it again. Woo! Ting 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 ting. Okay, we can take a look about it again. This one, 3D chamfer. This is the 3D chamfer. And the second one, project toolpath, but no trick. This is the secret toolpath, but no trick apply, so it still have bad results. And the final, the secret toolpath, but with trick. Okay, so we need trick on this case, and it's work great. You can see, wow, it's crazy. It's very beautiful, right? We have a constant chamfer. If you like it, you just apply it. I don't know which kind of chamfer you may prefer. Maybe some of you may like this kind of chamfer. I just want to give you more option for chamfer, right? If you don't like it, you can change to this, and if you don't like it, you just keep it the easy way. No trick needed. Just select the chamfer toolpath or project toolpath. You got it. No trick. But when you have trick, you got something different like this. Okay. Alright, so that's all for today. I hope this trick will be useful for you. And thank you for watching, and goodbye for now. See you.